Hello and welcome to another video by Johnny. So in this video I'm excited to show you a quite interesting part, but some people find it very difficult about inorganic chemistry, and it's called quantum numbers. So this episode, I don't know which episode it is. I may name it like 4, 5, 6, 7, who cares, but if you haven't watched my first and second episode, I would recommend you to do it now, because in those episodes, the first and the second one, I talk about orbitals and electron configuration and everything. So please do check out this episode first, okay? Before we go on. So in this video, okay, let's talk about quantum numbers now. So what are quantum number? So basically, when you do the electron configuration, the last electrons you put in there, the last like arrows you put in there, it's gonna be the what is it called? The address of the last electron you put in there is gonna be the quantum number. For example, I'm gonna do the first example for you. So before we go on, I think it's better to tell you what quantum number there are. There are 4 quantum numbers: the N, the L, the ML, and the MS. So it's like an address. So like I said, it's like an address of the last electron you put in there, the electron configuration. So address, you have, like, for example, country, city, what district, what is the street name, and maybe sometimes street number as well. So like an address, okay? So first thing first, the N is the first quantum number. It tells you the last electron you put in there belong, okay, so which groups, which period it belongs to. Excuse me, this one is which period. Which period it is. And then the next quantum number tells you the angular momentum quantum number. It tells you exactly what orbital it is. So which orbital it is. For example, if it ends up in orbital S, you write number 0. P, you write down number 1. D, you write down number 2, and F is number 3. Then the next quantum number is the ML, which is a magnetic quantum number. So the orbital that the last electron end up in, sometimes it might belong to maybe S, P, D, or F, but because S has 1 square, P has 3 square, D has 5 square, and F has 7 square. So to know exactly which square it belongs to, we divide like this. So the middle square always bear number 0. The middle square, you see, the middle one among them all is 0. On the left is negative, and on the right is positive, you see. So negative 1, negative 2, negative 3, plus 1, plus 2, and plus 3. Okay, so most of the time you will not even need to care about F, in your program study, in your program of study. So focus on S, P, and D, okay? So here is the, it tells you what square exactly that electron belongs to. And the last quantum number is the spin quantum number. It tells you if the electron is up or down, going up or down. So if the spin is up, you put plus half. If the spin is down, you put minus half. Okay. Alright. To recap a bit, just go back to the part when I explained about this thing. Okay. Now, let's do some example. For nitrogen's 14-7, you know that it has 7 protons. 7 proton and 7 electron as well. So the first one, 1, 2, 3, 4, and of course you have to half fill this one first according to Hund's rules. 4, so this is 5, 6, and this is the last electron you put in there, 7. As this is the last electron, you have to write its quantum number down. So in this case, it belongs to period 2, so this first quantum number is 2. Which orbital belongs to? P, so it must be 1 here. So which square? It's to the right of the center, so it's plus 1. And it's an up, so it's a plus half. There you go. 4 quantum number, like an address of the last electron you put in there. Okay, let's try some more example. Chlorine 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 of them, okay. 11, 12, 13, 14, 15. You see half field first, 15, 16, and this one is the last electron you put in there. 17, this one. So this one has 5, okay. Alright, so the quantum number for these electrons. Period 3, it belongs to P, so 1. It belongs to the middle square, so 0. And it's going down, so it's minus half. Okay. Quite easy, right? From electron configuration to find quantum number is actually quite easy, but in your program you might be asked to do the opposite. We'll go to that later, okay? Okay, let's do phosphorus, silicon, and aluminium. Your turn. Please pause the video and do it. Phosphorus, silicon, and aluminium. Just pause the video and do it. Okay. Phosphorus 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this one is the last electrons. Okay, so the quantum number? Period 3. It belongs to P, so 1. It's to the right of the center. And then plus 1. And it go up. Plus half. Okay, do you get the same answer? Okay, how about silicon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14 in this one. Okay, so how do you write this one? Third period is a P. It's a center square, so 0, going up. Okay, the aluminium, can you guess is what it's gonna be? I mean, it's 1 electron less, so supposed to be there, and the other square are empty. So it should be 3, period 3, P. It lies to the left of the center square, so minus 1, and then plus half. Okay. Any question, just put it in the comment below, okay? Now come to part 2. Okay, so this is part 2. So sometime in some occasions, of course, not so rare, you are provided the quantum numbers. And If quantum numbers are known, they ask you to find the electron configuration of that element and then tells what that element is. Okay. So basically, I'll give you 6 different example here, so you will understand exactly what the job you have to do is. Alright, so let's look at this case. You have 4 quantum numbers, 3, 0, 0, and plus half. So you have to find out the electron configurations and what elements it is. So what element it is? So basically, look at this one. It's in the 3rd period, and because there's so many electrons I have to write, so I'm just gonna write neon, because you know neon it's 2010. So I already if I write like this, I save 10 electrons already. So there I can just use this quotation and use this mark. It's not quotation, I know. Sorry. So neon, if I write like this, it's 10 already. So you know the last electron you put in there is gonna lie in s orbital, because there you go, 0s. So it's gonna stop here, and because s has only 1 square, so 0 as well, and it's a go up. So it goes up. So basically this last electron goes up, and when it goes up like this, you know that there's no longer any electrons surrounding it. According to Hund's rule, remember, according to Hund's rule, always have filled the orbital first. So it means that if the last electron is up, it means that there's no longer any electrons elsewhere around it. So it means that this element has neon and plus 1 electron. So this element will be 11. Check out at periodic table. What is the element number 11? Sodium. Yes, very good. It's sodium. Okay. Case number 2. You're provided 3, 1, plus 1, and plus half. So you know that it's going to end up in period 3, 1, so it's going to be P, because you have to fill the S already, like full fill at first. Before you reach the P, so before you reach the P, you have to full fill the 3S already. So it has 2 already here. And then plus 1, which means it's going to land somewhere to the right of the center square. So it has to be here. And it's going up, plus half, it's going up. So it means that here, excuse me, I drop things all the time. Okay, so if the last electron is there, you knew that these 2 previous square has to already been filled. According to Hund's rules, remember? Left, and it's like going from the left to the right. This one, and this one first. You remember? That's according to Hund's rules. Half fill at first. Okay. Which means that if this square is already filled on the right, these 2 square has to be already filled before that. It has to be filled before this one. Okay. Is the logic too hard to understand? Okay, once again. You find out that this is the position of the last electrons. The last electron. But because it lies to the right of the center square, it means that the other square has to already been half filled according to Hund's rule. So it means that it's going to has to be like this, up, up, and up. And then, because this one is going up, plus half, So there's not going to be something like down here. No, it's just like this. So this element, what is that? Neon is 10 already. 10 plus 2 is 12. 12 plus 3 is 15. So this element will be 15. What is the element with the number 15 in the periodic table? Very good. It's phosphorus. Okay, case number 3. You have 3, 1 plus 1 and minus half. So this is a bit different situation now. So third period, it's a P. So when it reaches P, you know the 3s has to be already filled. Okay. When it reaches the P already, you know the 3s has to be already like fully filled, like up down already, fully filled. Okay. So 3p and then plus 1, which means this square on the right. So the same situation like this. And then it's going down. So it's like this. Going down. So what does it mean if it's going down and on this square? It means that all of these 3 square has to be up first according to Hund's rule. Half fill first. Before it can go down like this. And because it's the last square on the right, so it means that this square has to already been down as well before you can reach this one, right? Remember, you have to put like this, up, and then down, and then down, right? So this is the last electron. If this is the last electrons, all these things has to be already up first, and then down, before you can reach this one. Is the logic too hard to understand? Once again. You found out that the last electrons in this configuration belongs to this place, going down. So you knew that when something is going down like this, it means that there has to be up and up already. According to Hund's rule, you have to half fill the orbital first. So you have to have up and up already. And then, because this electron is going down at the last square, it means the other square has to already been filled as well. Because remember, oops, I'm dirtying my hand now. So, according to Hund's rule, half fill first. Before you can going down, and then this is the last one, it's going down. So it means that if the last electrons belongs to this position, all of them must already been fulfilled. All of them. So it has to be like this. And it stops here. So what is this element? So neon 10 plus 2 plus 6 is plus 8, so that's 18. What is the element that has the number 18 in the periodic table? Check it out, go check. Very good, that's argon. Argon. What's the other number? 39.9. Sometime I forgot. Okay, you do the 3 other cases. Pause this video and try to do the other 3 cases. Okay, after pausing and do the video, after pausing and do these 3 examples. So here's the answer. Third period, and then P, so this one has to already been fulfilled. P minus 1 is this one, and going down and here. So when you know when it's going down and it's going and it's like in the left square, you knew that this has to be half filled already. And because it's going down and it lands here at the left square, the other square will not be filled. The other square will not be filled according to Hund's rule, because it ends here. Remember? Here, here, and then here. But if it ends there, there will be no longer anything on the other square. Alright? So this is the last electrons there. 10 plus 2 is 12. 12 plus 4 is 14. Sorry. Sorry. 10 plus 6 is 16. Sorry. What is element 16? It's sulfur. Very good. How about here? Okay, so period 3, and it's a D. There you go. Remember that 4s stand before 3D, okay? 4s stand before 3D. Because even though 4s is like bigger in the period, but still, in the energy level, it's weaker than the 3D. So, it's like this. 3s energy level is lower. 3p, 4s, and then finally 3d. So 3s, 3p, 4s, and then 3d. It's like this. Okay. So it lies in D, right? It means that all of these things has to be filled already. Before you reach the 3D. And now it lies in plus 2, which means in here. It lies in this last square, and it's going up. Going up. What does it mean? If it lies in the last square and it's going up, it means that all these square has to be half filled already too. And if it's the last electrons, it means there's no going down. There's not going down anymore. It's because it's the last one. No going down anymore. So 3d5. So what element is this? Okay, D. So it belongs to the transition metal. Okay, so 10 plus 10, 20 plus 5, 25. What's element 25? Check the table. It's manganese. Manganese. Manganese 25. What's the other number? 54.9. Alright, the last case, same thing. It lies in 3D, which means all these things has to be filled first. And then it lies in the -2 square, so all the way here, so here, and it's going down. So when it's going down, you know that all these things has to be half filled first before it. And then, because it's going down and it's here, this is the last electrons you put in there. And there's not going to be any down here, no. So this is the last electron you put in there. And this 3D has 6 electrons. What element is this? 10 plus 10 is 20 plus 6, 26. What is element 26, guys? Yes, it's iron. 55.8. Okay, I hope the video was helpful for you. You can try the other quantum number. Try it out at home. Just try to make your own quantum number, and there's a lot of other exercises online about quantum numbers. You can do it, or if not, you can just make up your own quantum number and try to practice practice both way, okay? So both ways. To know quantum number, find electron configuration and element. And the other way around, which is easier. From the configuration, you get the quantum number. So practice makes perfect. I hope the video was helpful for you. Please like, subscribe, and share my video, okay? As always, the details can be found in the video description below, okay? Bye bye, see you.